Welcome. In this video I'm going to show you how you can perform a one sample Wilcoxon signed rank test using Excel and my stikpetE add-in. My add-in can be downloaded from my GitHub account. The link is over here. And once you've downloaded the file, you can don't open it with Excel, just open Excel and then go for File, Options, Add-ins, and then click on the Go button. Then browse for the file and it should install and give you access to a lot of additional functions. The advantage of my function is that it can also deal with non-numerical data. This one sample Wilcoxon signed rank test can be used in case you have an ordinal variable and you want to see if the median is a specific value in the population. Alternatives would be the one sample sign test or a one sample trinomial test. I have two examples. In column A I put some data that is already numerical, and in column B I actually have the data where it's not numerical but is ordinal. The function has one must input parameter, which is of course the data itself. Please do not select an entire column, just specify the range from the first cell to the last cell, and always vertical. The levels is if you have non-numerical data, so below here as you can see I specified which categories there were and put them in order. Mu is the hypothesized median. This will actually give you the which median you want to test for. If you don't specify it, it will simply take the mid-range, which is the maximum plus the minimum divided by 2. You can indicate what it is if you want to use a tie correction. The default should be true. Then the test itself will calculate a specific value, usually as a t-value. And that follows a Wilcoxon signed rank distribution, but it's often approximated using a normal distribution. So if you want to use an approximation rather than exact, you can use Wilcoxon, which simply uses the normal distribution, or Iman, who actually made also an alternative normal distribution approximation and a student t approximation. You can also specify what to do if the scores are equal to the hypothesized median. You can either use Wilcoxon, which basically says to remove them, and pret and set split actually keep them in and adjust the test statistic accordingly. If you're using an approximation, then a continuity correction is usually also an option. So if you want, you can simply set that to true. In the end, the result that you will get is actually a range of 2 by 7 rows, and it's perhaps easiest to use an example. So here I've used the function, specified the range with the numeric data, and it immediately gives me all of this as a return. It's the number of ranks that was actually used in the calculation, the hypothesized median, the sum of the ranks with positive differences, the test statistic that was used, so in this case a z-value, the degrees of freedom, which is only applicable if you're using the Iman's student t distribution approximation, the p-value, which in this case is extremely small, and a small description of the test that was used. As you can see, I have the exact same results if I'm using the same function, but now I specified the non-numerical data and then also gave it the levels. Alright, I hope this video was helpful, and thank you for watching.